this is one of the topics in meteorology that makes me smile. Now, we oftentimes see, like, if this is my piece of paper going kind of tumbling across from location A to B, and you're like, well, why did that piece of paper go tumbling from A to B? Well, of course, there is some wind going on. You'd be like, okay, so what created that wind? And sometimes we just take it for granted that it just magically appeared. But what created that wind actually was because there was a high pressure over here and a low pressure over here. Think of it that way. Okay, so basically all wind is air being pushed from a high to a low pressure. And if you think of blowing up a balloon, okay, so I'm going to blow up a balloon, okay, and this is my business end. This is where I put the air in. I guess I should make it circular, and I'm blowing up this balloon, and then I'm going to go ahead and let it go. I'm going to open it up, and of course the air is going to come out, shoot out, and it's like a Newton's sort of law. The balloon is going to go this way, and the air is going to go this way. Okay, so that is actually, why does the air come out of the balloon? Well, it comes out of the balloon because there's a high pressure in here and there's a lower pressure out here. That's why the air relocates and creates wind. Okay, so that's just it. I mean, if you have a fan, and this is not going to be a very good picture of a fan. Here's my fan. Oh my goodness. And you're waving the fan kind of back and forth, okay? What you create a wind. You're like, all right, how to create that wind? Well, as you move the fan, for instance, this way, you create a high pressure that actually then bumps the air particles this way, creating a breeze. Okay, you bump it that way, it creates a high pressure, and it bumps the air particles that way, creating a little wind. Okay, so I mean, that's all wind is air moving from a high to a low pressure. That's it. So here we've got, pull up both of these examples, we've got things we talked about in a previous lecture. Of course, MB, hopefully you're thinking pressure, that stands for pressure, 1016 millibars, 1012 millibars, 1008 millibars. Well, goodness, this is getting lower pressure this way. So here we have a high pressure, here we have a low pressure, and this actually then, these arrows, are what we call your pressure gradient force. They're actually what's going to drive your air particles from, in this case, left to right, from high to low pressure. Pressure gradient force. I can't remember how much I talk about it in Exploring Physical Science, but we talk about this a fair bit in my 16-week course in meteorology. This is abbreviated PGF, pressure gradient force, from high to low. Over here, you probably, hopefully recognize these isobars. We might have, a high pressure up here, kind of in a low pressure here. I can tell that by looking at these millibars here. So then we would generally have a wind going this way from high to low. Now actually we're going to kind of change that up here in a little bit and introduce something called the Coriolis force, which kind of gives a twist around a high pressure. But that's what we're talking about. Winds, well, they can be, we're going to talk about different scales of winds in the next part, kind of your little dust devil wind or your global wind. Short or long lasting, large scale, small scale. Okay. So this did talk about pressure gradient force. All the pressure gradient force is kind of the push from high to low. That's your pressure gradient force. Now notice that if we go down here to this, looks like a football field. If we go down to this part of the football field, notice where these spacing, we have small spacings, and actually on a previous lecture I said that that is a tight, or did I call it tight, pressure gradient? Okay, when the spacings are closer, then actually you have a stronger PGF, stronger pressure gradient force, and that creates a stronger wind. So one of the things I think is kind of fun is if you are having a very, very windy day, pull up a what we call a surface map that gives these isobars and see how closely spaced your isobars are with your crazy strong pressure gradient force.